For thousands of years, humans have looked up at the night sky and witnessed stars suddenly appear where nothing existed before. Ancient astronomers called them new stars. Today, we know they are supernovas, some of the most powerful explosions in the universe. But there has always been one major problem. By the time astronomers noticed a supernova, the most important part was already over. The first moments of the explosion happen incredibly fast. They are gone within hours, sometimes even minutes. Scientists could study the aftermath, but they could never directly observe what the explosion looked like when it first began. Until now. In a breakthrough discovery, astronomers have, for the first time in history, watched the shape of a supernova explosion in real time. This achievement is helping scientists answer one of astronomy's biggest mysteries: what actually happens inside a giant star during its final moments. To understand why this discovery matters so much, we first need to understand how a star dies. Massive stars spend their entire lives fighting a constant battle against gravity. Gravity is always trying to crush the star inward. To resist this pressure, the star produces enormous amounts of energy through nuclear fusion. Deep inside its core, lighter elements combine into heavier ones, releasing energy that pushes outward. This balance keeps the star alive. For millions of years, the star burns different elements. First hydrogen, then helium, and eventually even heavier materials. But one day, the star reaches a dangerous point. It begins producing iron, and iron changes everything. Unlike other elements, iron does not release energy when it fuses inside the star. Instead, it acts like a dead end. Once the core fills with iron, the star can no longer create enough energy to support itself. The battle against gravity is lost. In just seconds, the core collapses inward at incredible speed. The outer layers of the star then crash toward the center. When all that material slams into the extremely dense core, it rebounds outward, creating a gigantic shockwave. That shockwave tears the star apart. A supernova is born. The energy released during this event is almost impossible to imagine. In a single explosion, a supernova can release more energy than our sun will produce during its entire lifetime. For months afterward, the explosion can shine brighter than entire galaxies. Yet despite all this power, scientists still weren't completely sure how the explosion actually develops inside the star. That's why what happened in April 2024 was so important. On April 10th, a sky monitoring system called ATLAS detected something unusual. ATLAS constantly scans the sky, searching for dangerous asteroids and strange cosmic events. When it spotted a star beginning to explode, astronomers immediately knew they had a rare opportunity. Within just a few hours, scientists pointed one of Earth's most advanced observatories toward the event, the Very Large Telescope in Chile. Their timing could not have been better. For a brief moment before expanding gas hid everything from view, astronomers captured something nobody had ever seen before. They observed the actual shape of the explosion, and it wasn't what they expected. Most scientists assumed a supernova would explode in a nearly perfect sphere, expanding evenly in all directions. But that isn't what they found. Instead, the explosion appeared slightly stretched, almost like an olive shape rather than a perfect ball. At first, that may not sound like a huge discovery, but for astronomers, it was shocking. The shape of an explosion can reveal what caused it. Think about throwing a stone into a calm pond. The ripples move outward in perfect circles because the energy spreads evenly. But if energy is released unevenly, the pattern changes. The same idea applies to supernovas. By studying the shape of the explosion, scientists can learn what was happening deep inside the star just before it died. To make these observations, researchers used a special technique that studies how light waves move and scatter through space. This allowed them to detect details that would normally be impossible to see. As the explosion expanded, it eventually slammed into gas surrounding the star. The shape changed somewhat, becoming flatter over time. Yet something important remained the same. The explosion kept expanding along the same direction. This detail may help solve a long-running scientific debate. For years, researchers have argued over two major explanations for how supernovas explode. The first theory involves tiny particles called neutrinos. Neutrinos are incredibly small particles produced in huge numbers during the collapse of a star's core. According to this idea, neutrinos heat material around them unevenly. The heating creates turbulence and instability, causing the star to explode in a chaotic and messy way. In this scenario, the explosion would not have a clear structure. It would be rough and irregular. The second theory is much more dramatic. Some scientists believe powerful streams of energy shoot outward from the star's core before the explosion fully develops. These streams act almost like giant cosmic drills. They punch through the star's interior and force the explosion outward in specific directions. If this theory is correct, the explosion should look more organized and symmetrical, and that's exactly what scientists observed. The newly studied supernova showed a surprisingly clear shape and direction from the very beginning. It didn't look random. It didn't look chaotic. Instead, it appeared organized and structured. This evidence suggests that powerful energy streams may play a major role in driving these enormous explosions. Although scientists are still studying the data, the discovery provides one of the strongest clues ever found about what happens during a star's final seconds. But the story doesn't end there. Supernovas are not just distant cosmic fireworks. In fact, Earth may still be feeling the effects of ancient supernovas today. Recently, scientists studying Antarctic ice discovered something remarkable. Hidden inside the ice were tiny traces of a rare radioactive element called iron-60. Most iron found on Earth is iron-56. Iron-60 is different. It is extremely rare and gradually disappears over millions of years due to radioactive decay. Most importantly, iron-60 is often created during supernova explosions. In simple terms, scientists found microscopic pieces of ancient star debris frozen in Antarctic ice. At first, this discovery was confusing. The snow where some of the material was found was less than 20 years old. If a nearby star had exploded recently enough to send fresh debris toward Earth, people would certainly have noticed. The sky would have displayed one of the brightest events in human history, but no such supernova occurred. So where did the iron-60 come from? The answer appears to involve a massive cloud surrounding our solar system. Scientists call it the local interstellar cloud. For years, researchers suspected this cloud formed from the remains of one or more ancient supernovas. The discovery of iron-60 strongly supports that idea. It suggests that debris from long-dead stars is still drifting through our region of the galaxy, and some of those tiny particles continue falling onto Earth even today. To investigate further, scientists examined deep-sea sediments and ice cores dating back tens of thousands of years. Layer after layer revealed more evidence. The amount of iron-60 changed exactly as expected if Earth had been moving through a giant cloud filled with ancient supernova debris. The findings paint an incredible picture. Long before humans existed, nearby stars exploded and scattered material across space. Millions of years later, traces of those explosions are still reaching our planet. Even more amazing, many of the atoms inside your body may have originated in ancient supernovas. The oxygen you breathe, the calcium in your bones, the iron in your blood. Many of these elements were forged inside stars and spread across the galaxy when those stars exploded. In a very real sense, we are made from star material. Supernovas also create something called cosmic rays. When the blast wave from an explosion crashes into surrounding gas, it produces powerful magnetic fields. Tiny particles become trapped within these fields and accelerate to incredible speeds. Eventually, some of them escape. They travel across the galaxy as cosmic rays. When they reach Earth, they collide with atoms in our atmosphere and create invisible showers of particles that constantly pass through us. Most people never notice them. Yet they are another reminder that the universe is far more connected than it appears. And now, thanks to one extraordinary observation, we are finally seeing these cosmic events in a completely new way. For the first time ever, humanity didn't just observe the aftermath of a supernova. We witnessed the explosion itself. We saw its shape, we tracked its direction, and we gained valuable clues about the forces that destroy giant stars and create the building blocks of worlds. After decades of questions, scientists may finally be getting closer to understanding one of nature's greatest explosions. If you enjoyed this video, don't forget to like, subscribe, and turn on notifications for more content like this. See you in the next one.